Okay, so one of my students had asked this question uh, of this definite integral, wherein the lower limit, this is particularly the lower limit of the integral, lower limit of the integral, and this is the upper limit of the integral. And this particular expression is the integrand. This particular expression is the integrand, and dx is the differential coefficient. We say this dx is the differential coefficient. So the expression, the integrand is x upon secant x multiplied by cosec x, wherein we know that the secant x is nothing but the inverse of cos x, and vice versa, like cos x can be said as the inverse of secant x, and we know that cosec x is the inverse of sin x. So before we get into solving this integral, this definite integral question, we need to be through with one property, one very important property of definite integral, which says that if there is any expression f of x dx and we are calculating its integral wherein the lower limit is a and the upper limit is b, this is equivalent to saying the integral of f of a plus b minus x dx wherein the lower limit is a and the upper limit is b. Now let us try to first prove it. So let us try to first prove this property, because in mathematics we nearly have proofs for just everything. We cannot make vacuous statements. We need to substantiate our conjectures with firm logic and reasoning. Only then we can surmise that our assumption is correct and we can use that property in solving a variety of questions in mathematics. So let us assume it as I, which is equal to a to b f of x dx. This integral I have assumed integral of fx to dx from a to b as I. Now we will substitute, put x is equal to a plus b minus t, and now you will see, and we will differentiate also this equation with respect to t. So if we differentiate dx upon dx, we will differentiate it, okay, so we will differentiate it with respect to x, so it comes to d of dx x is equal to d of dx a plus d over dx b minus dt over dx. And by a very common reasoning, we know if the numerator and the denominator are same, that reduces the expression to a unity or the numeral 1. Since a and b are constant numbers, these two particular values a and b, of course we can see from here that a and b are merely numbers. They are constants, they aren't changing. What is changing is that this differential coefficient and the functional value, but a and b in particular are basically constant. They are merely numbers and they are constants. And anything when differentiated with respect to a constant, that gives us the value 0. The differentiation of any constant value is exactly equal to 0. We have studied that in the differential calculus. I've explained and I have given the proof for it, because nothing is changing with respect to the change in x. So the constant value will remain the same. So basically, in the expression of d over dx, we are measuring the change. And when something is constant, it isn't changing. So that change is 0, nothing is changing. So this is 0. So this value is 0. Again, this value is 0. And this is minus dt over dx. So this, we can simplify it further. 1 is equal to minus dt over dx. And dx over minus dt, or we can multiply this expression by minus 1. We can very comfortably say that dx is equal to minus dt. So let me go back again. We had assumed this integral of a to b fx dx, wherein the lower limit is a, the upper limit is b, the differential coefficient is dx, and the function, and it is a function of x. So I have assumed it the value I. So I is equal to, I have assumed I is equal to a to b fx dx. Now what I did was that put, I substituted x with a plus b minus t, wherein a and b are merely numbers or constants. And again, t is a parameter. Its value depends on x. T is a parameter. Its value depends on x. We will see in later proof the usefulness of the parameter t. Parameter is something which is depending upon the other quantity. So as x is changing, hence t will change, or as t changes, x will change. So upon taking the differential coefficient of everything with respect to x, we have taken the differential coefficient with respect to x of the whole expression. So that gives us dx is equal to minus dt. And now if x is equal to a, then a is equal to a plus b minus t, which gives us the value b is equal to t, or t is equal to b. We have substituted the lower limit in place of x because we need to change. See, in definite integral, whenever we are substituting something, we need to change the limits accordingly, because if we don't, then we will end up getting a wrong answer, because we have not changed the lower and the upper limit with respect to t. We now need the expression in t. And if x is equal to b, then b is equal to a plus b minus t. The left hand b and the right hand b gets cancelled, and we are left with t is equal to a, because the negative sign will get cancelled. So t is equal to a. So now we can change the lower limit and the upper limit. Okay, so now what we will do is, now the integral I will change to integral negative a to b f of a plus b minus t dt. Okay, and we have one more property, if you recall it, that, see, what we did, what exactly we did was that it was x is equal to a and t is equal to a and t is equal to, see, when x is equal to a, t is equal to b. Okay, so it has to be the lower limit and the upper limit are changed accordingly. Okay, so when x is equal to a, t is equal to b. So let me correct it here. This is b and this is a. Okay, so what we actually did was that initially if we compare the expressions, so it was a to b f of x dx. All right, so initially this lower limit when x is equal to a, t came out to be b, which we have substituted it here, and when x is equal to b, t came out to be a, which we have substituted it here. All right, okay, so this is b to a. The integral is now b to a f of a plus b minus t dt, and we know that how did this negative sign came? This negative sign, okay, we had done this differential coefficient dx is equal to minus dt. So when we replace dx, see initially we had dx and now we have replaced it with dt. Okay, so dt came along with a negative sign. So we have taken, see all the negative signs with the positive sign, it is self-understood that we don't need to, add or take it out. It is self-understood that if there is no sign, then it is a positive sign. But if there is a negative sign, we need to show it clearly. So there is a negative sign, and we have taken it out of the integral. And now if we, okay, so we had already seen that there is a property that if a to b fx dx, which will be equal to b to a fx dx. Okay, so whenever lower limit and upper limits are interchanged, we need to have this negative sign. See here was no sign, such sign. Okay, we need to have this negative sign once we change the lower limit. So we have actually changed a has gone here, b has come here. Okay, so whenever we change the limits, change as in the lower limit becomes the upper limit and the upper limit becomes the lower limit. Okay, changing doesn't mean that we can arbitrarily substitute any value. No, we can't. Changing here the word change means that I have changed the lower limit to upper limit and the upper limit to the lower one. Okay, so in this interchange, we need to add this one extra negative sign. Okay, so in this particular integral, now we need to see that there was a negative sign. Okay, and okay, so what we had was integral minus b to a f of a plus b minus t dt. Okay, and now since we, of course, where did this negative sign came from? The expression dx is equal to minus dt, and now we can change the lower limit and the upper limit, we can interchange them. So this expression will become a to b f of a plus b minus t dt, and one extra negative sign, so minus 1, it's like minus 1 into minus 1. This will change to plus 1. So a to b f of a plus b minus t dt. So this integral is I is equal to a to b f of a plus minus t dt. The function okay, so this negative 1 into negative 1 becomes the positive 1. Okay, so we don't need to write it, it's understood. If there is no sign, this is understood that it is a positive sign. Okay, so now we have got the expression that if if a to b fx dx, this can be changed into a to b f of a plus b minus x dx. But one thing we have to be okay, so we just proved this. Okay, so one thing we have to be very particular in the use of negative sign, in the use of positive sign, in interchanging the upper limit and the lower limit, and in substitution, in taking the differential coefficient, and we will just prove it this. Okay, so now getting back to the question part. So how can we use this property in solving this question? So please observe this integral very carefully, that this 0 is the lower limit and pi by 2 is the upper limit. So what we can do is we can say that let us assume this integral to be I. Okay, so this will become 0 to pi over 2 x over secant x cosec x dx. Okay, and this will become 0 over 0 to pi by 2, and this will we can take, using this property, the property which we just discussed, as pi by 2 minus x. We replaced I with pi by 2 minus x and secant pi by 2 minus x cosec pi by 2 minus x and the differential coefficient. Okay, so this value, this again value is equal to I. Okay, so this value again is equal to I. And okay, so pi by 2 minus x, what does this mean? This means that we are still in the first quadrant. Okay, so pi by 2 minus x is like we are still in the first quadrant, and here all the trigonometric ratios, are positive. So secant of pi by 2 minus x will, okay, and but whenever we have a 90 degree and whenever we have 270 degrees, okay, so the trigonometric ratio changes. So secant, okay, so the trigonometric ratio changes. So secant x will become cosec x, and the cosec pi by 2 minus x will become secant x. Sin x, okay, sin changes to cos, cos changes to sin, secant changes to cosec, cosec changes to secant, cot changes to tan, and tan changes to cot. Okay, so whenever we have 90 degrees, whenever we have like let us say that sine 270 degree minus x, or cos 270 degree minus or 270 degree plus x. Whenever we have expressions like wherein we have 90 and 270, so the trigonometric ratio will change. And in the case of, let us suppose we have 180 degrees, 0 degrees, 180 degrees, and 360 degrees. Trigonometric ratios continue. Trigonometric ratios continue being the same. They don't change. So, going back to the question. So now our integral will become I is equal to the lower limit is 0, the upper limit is pi over 2. See, still the limits are the same because, you know, we still the limits are same because we haven't substituted any parameter as yet. Okay, so we won't change the limits. Wherever we change the limits whenever we use the parameters such as t, x, phi, or anything, you know, we haven't used the parameter. What we have replaced is we have replaced x by pi by 2 minus x. Why? Because we have just seen the property that, you know, a was a constant number, b was a constant number, so we can change it. A plus b, in the proof we had replaced x with a plus b minus x, and now here we have changed x with pi by 2 minus x. Both are numbers, so there is no parameter. So still we, you know, we won't change the limits. It's pi by 2 minus x upon cosec x secant x. I is equal to, we'll take the pi by 2 since it's a constant value, and we will take it outside the integral sign, and this will become 0 to pi over 2 dx over cosec x secant x minus 0 to pi over 2 x upon cosec x secant x. Okay, and recall that this particular expression, this is nothing but the I. Okay, recall the question. The question was, okay, the question was 0 to pi over 2 x upon secant x cosec x dx. So the differential coefficient was dx, and the integral was 0 to pi over 2 x upon secant x cosec x. So okay, so we have it. Okay, so this was the proof. Okay, let me switch to the question part. All right. So now what we are left with is I is equal to pi over 2 0 to pi by 2 dx over cosec x secant x minus 0 to pi by 2 x dx cosec x secant x. All right, so this thing we know is nothing but the I, and we'll take it to the LHS part. So this will become twice of I is equal to pi over 2 0 to pi by 2 dx over cosec x secant x. Okay. Now, a close observation will enable us to see that we can take it to the numerator part. The cosec will become the sin x, the secant will become the cos x, since I had already told you that the secant and the cos are nothing but the inverse of each other. And this dx. Alright, so what we can do is we can multiply a 2 here and we can divide a 2 here. So this expression will become twice of I is equal to pi over 4, 0 to pi over 2 sine 2x dx, twice of I, and the integral will become I is equal to twice of I is equal to pi over 4, and we know the integral of sine 2x, that is cos 2x upon minus 2, wherein the lower limit is 0, the upper limit is pi over 2, and 2i, this will become 2i is equal to pi by 4 cos 2x. You can take the minus sign out, not an issue. Or okay, for now just just keep taking it inside, so as to avoid any ambiguity in the calculations. 2i is equal to, okay, so now take the 2 part here, it will become pi over 8, and this will become, okay, so now taking, if we substitute the values, so this will become cos of pi, cos, we have taken the 2 out, so it's still 2i is equal to, now we can take the minus sign out, minus pi by 8. We have taken this minus sign out, and we have taken this 2 minus 1 by 2 out, so it will become minus pi over 8, and in it we are left with cos 2x, 0 to pi over 2, so will become 2i is equal to minus pi over 8, and evaluating the integral, this will become cos of pi minus cos of 0. This will become, now this is simply a very simple calculation. Now there is nothing so intriguing in the calculation. So cos of pi, we know that is minus 1, and we know the value of cos 0 is again 1, but with this negative sign it will become minus 1, and what we are left with is 2i is equal to 2 pi over 8. Okay, and now solving it here, so this I will become pi over 8, which is actually the answer. The value of I came out to be I is equal to pi over 8. So this is a very easy calculation what we started, and with a little bit of intricacies, ended up with a very simple calculation. You just have to follow the proof, you just have to follow the theorem and the property of the definite integral that we discussed, that the property was that if we have negative a, so this is particular the property, so you just have to just keep in mind this property, this particular property, okay, this particular property, that if we have anything we have like f of x dx, okay, so f of x dx is equal to a to b, the lower limit is a, the upper limit is b, we can replace it with a plus b minus x dx. You just have to follow this property, and we will end up with a very simple calculation, and the very difficult looking integral will become very simple for us to calculate, and there is nothing difficult in this. With just following this property, we can solve this. Okay, and we will end up getting the answer as pi over 8, but you just have to keep in mind the negative sign, the numbers. Just don't mess up things, because it's a very simple question. Don't confuse yourself with a very silly mistake, and we will end up getting a very simple answer, that is pi over 8. Thanks for watching the video.